our focus is 0, comma p. So when we're looking at that y equals 1 over 4px squared, the focus is 0, comma p. The directrix is y is equal to negative p. And that's it. That's all we have for this here. We have these two main parts. Now, it tells us that if p is greater than 0 or p is positive, it opens up. Now, if p is negative, it opens down. And for this one here, we also have the axis of symmetry is x equals 0. That just tells us right at the top. Vertical axis of symmetry, x equals 0. Now for other equation, x equals 1 over 4p y squared. This one here, it tells us the focus is p comma 0. Our directrix is x is equal to negative p. Now this time if p is positive, it opens to the right. And if p is negative, it opens to the left. So right is going to open this way, left is going to the left. Down, up. And we have these here. And the main thing we'll be looking at, especially with these first four, is finding the value of p. You're welcome. It's finding the value of p. So when we look at these here, we're wanting to find the value of p. Because if we can find the value of p, we'll be able to find the focus. Because the focus is either 0, comma p or p, comma 0. The directrix is either y equals negative p or x is equal to negative p. So again, it's the all revolving around the value of p. Because when we have the value of p, we can find the focus, directrix, we can have all of this here. And the other thing we need is the axis of symmetry. Now the equation they gave us is negative 4x equals y squared. That's the equation we're looking at. That's the one we're trying to get this information from. Now when I look at that there, what variable is squared? What variable is to the second power? Well, which one has the second power there? It's the y, isn't it? Because y is squared. So when I look over this at the equations we had, we have y equals 1 over 4p x squared, and we have x equals 1 over 4p y squared. This one has y squared, doesn't it? That's the one we're going to use. We're going to use all the properties of the one that has y squared. So it tells me that the focus is p comma 0. It tells me the directrix is x is equal to negative p. And it works out that the axis of symmetry is y is equal to 0. It tells us right there in our set that you guys have on your sheet that the axis of symmetry for this is y equals 0. So out of the three things we need to solve for, the vertex, the focus, the directrix, and axis of symmetry, we have almost everything. Because the only thing we're missing is the value of p that goes here and here. These two values, if I have the value for p for both of those, we're done. And that's what we're going to find. Because once we find the value of p, we plug it back in and we're done. Now the equation we're relating this to is x is equal to 1 over 4p y squared. Now let's see what we have. We have negative 4x equals y squared. Now if you notice in both of those general equations, the variable that doesn't have an exponent is by itself. X equals 1 over 4p y squared. The term with the y squared, the term with the exponent, has everything else with it. The term for the first, so x or y, so x here in our general equation is by itself, yes? So what we're going to do is we're going to get it by itself. So for all these here, when we're working these here, we want to get the variable without an exponent by itself. So is it by itself? Well, no, we have negative 4x, yes? So we need to get it by itself. How can I get it by itself? We can divide both sides by -4. Because -4 divided by -4 will simplify, leaving me with x by itself. Because that gets x by itself, yes? Because -4 divided by -4 will simplify. And what I have left over here is y squared over -4. So is x by itself? Well, yes, it is. We do have x by itself, but we're going to make one little adjustment. I'm going to move the y squared out to the side instead of leaving it in the numerator. Does this change anything? Well, no, it's just saying -1/4 times y squared. These two are saying the exact same thing. They're saying the exact same thing. I just have it off to the side instead of up in the numerator. Are we good with this here? Yes? Now, I did this for a reason. Because what are we trying to solve for at this point? We're trying to solve for the value of p. Because if I find the value of p, letter p, I will have the x value of the focus, which is the only thing we're missing, and I will have the value of the directrix that goes here. Yes? Because if I have those things, we're done. I mean, besides graphing, we are done. So I set it up this way here. Now, what was our original equation? 1 over x equals 1 over 4p y squared. Do these look similar now? They look very similar, don't they? Because we have here x by itself. Here we have x by itself. Y squared, 1 over 4p, and -1/4 now match up, don't they? That's why I wrote it this way. That's why we worked it this way. Because now 1 over 4p is matching up with our -1/4. Would y'all agree with that there? So we set it up and get it to this point here to find the value of p. Now the way that we're going to do that is I'm going to take 1 over 4p and set it equal to -1/4. Because that's where the value of p is located. For this problem, it's located in that -1/4. So we got the equation set up, and we worked it so we had x equals, so here, -1/4 times y squared. The -1/4 is where we're going to end up finding the value of p. So we set 1 over 4p equals -1/4. We set them equal to each other. Any questions on this here? The next step in solving for p will be the exact same for all of these here. What we're going to do next is we're going to multiply both sides by 4p. So the first step we do in solving for p is we're going to multiply both sides by 4p. Because we need to get the variable out of the denominator, out of the bottom of the fraction. Because these two here will simplify out, leaving me with 1. Here, we'll get -4p over 4. Well, -4 divided by 4. Well, 4 divided by 4 is 1. Anything divided by itself simplifies to 1. So -p. I don't care about the value of -p, so I'm going to divide both sides by -1. And when I divide both sides by -1, I get -1 is equal to p. Yes. You're welcome. So we first step in solving for this here is we multiplied both sides by 4p, which gave us 1 on the left-hand side and -4p over 4. Well, 4 divided by 4 gave us -1 and -p. And then when we divided both sides by -1, it gave us that p, because it's now positive, equals -1. So we found the value of p. Any questions on this here? Because that was our goal. Our goal was to find the value of p. And now that we have the value of p, we can come back up here. Because we have p is negative 1. So our focus is negative 1, 0, because that's the value of p. We plug it back in. Now the directrix is x equals negative p. So x is equal to negative, negative 1. Well, a negative and negative make a positive, so the directrix is x equals 1. And that's it. That's all we have to do here.
So when you divided negative p by negative 1, that was just find the
Value of p. Because we could have multiplied it by negative 1 also. We're just trying to make the value of p positive.
okay. So it's still negative on the focus.
So on the focus, it's negative because, so we had negative p equals 1. Well, let's say I multiply.
Okay, I got p equals negative.
Mm-hmm. Yep, so p is equal to negative 1 for this here. So that gave us our negative 1, 0. Now, because of the double negative for the directrix, we got to change the sign. So since it's negative, it's now positive. X equals 1. And that's it. That's all we have to do for this here. Now, graphing it, we can use the graphing calculator. I would use this information here because it's going to have it labeled. It's going to have the directrix and focus labeled. So the focus, negative 1, 0. So I'd see which one of those four has a focus, and it'll say focus, of the point negative 1, 0. And I directrix of x equals 1, that line. And out of the four, there's probably only going to be one that has it. The other thing we have is that the focus, the value of p is negative 1, yes? So looking at x equals 1 over 4p, if p is negative, it opens to the left. It should look like this. It should have an open towards the left. So on the graph, if we were to graph this thing, it should be opening that direction. It should be opening to the left. I have a feeling it's probably going to show you four graphs. One opens up, one opens down, one opens right, one opens to the left. So it opens to the left. Questions on this here? So these here aren't bad as long as we stick to these formulas and trying to match this up and finding p. Let's look at another one. Now the first thing I always look for when looking at this here is what variable is squared. Which variable is squared? Is it x or y? Y. It's the y value. So I go straight to the equations for y. So the focus is p comma 0. Our directrix is x is equal to negative p. And the axis of symmetry is y is equal to 0. Now on the homework assignments, probably, well, you got 1 point there, you got 1 point there. We're just missing 3 things. So out of the 5 things you've got to put down, we're almost halfway done, aren't we? Because I've identified that this is dealing with the x equals 1 over 4p y squared. This information here, we're just copying it down because this is the one, this is all the information the graph is going to go to. It's going to connect to. Do you all see this here? Yes? Now what are we missing? We're missing the value of p. So this is connected to x is equal to 1 over 4p y squared. What do we have? Negative 2x equals. So what do we need to get by itself? What variable do we need to get by itself? We need to get the x by itself, yes? Because the variable we need to get by itself is the one without an exponent. We need to get the variable without an exponent by itself. So how can I get x by itself? We need to get rid of what? The negative 2. And we would do that by dividing both sides by negative 2. Because negative 2 divided by negative 2 is 1. Anything divided by itself is 1. So those two would simplify out, leaving me with just x is equal to y squared over negative 2. Now I rewrite it like this here because I want that 1/4 so that we have what we're matching up with, 1 over 4p, to kind of be a little bit, we can see it more. We can see it better written this way. Because again, this is matching up to our 1 over 4p y squared. 1 over 4p is matching up with our negative 1/2. These match up. These connect. These connect. And so, to solve for 4p or solve for p, we set up 1 over 4p is equal to negative 1/2 or 1 over negative 2. They're the same thing. They're the same thing. Now, before we move on, are there any questions on how we've done any of this here? Okay. Now, what is our next step? Because next step, this is going to be the same on all of these that we're doing here. We're going to multiply both sides by 4p. We multiply both sides by 4p. Because 4p and 4p will cancel. And when we do that, we'll get 1 equals negative 4p over 2. Well, what's 4 divided by 2? 4 divided by 2 is 2, and it's going to be negative because we have negative. Last step in solving for p here. We need to do what? We need to divide both sides by negative 2. So we found the one variable we're looking for, yes? Because that's all we needed to find. Because our focus is p comma 0. Our directrix is y equals negative, or x equals negative p. Well, it's already negative, so it's going to become positive. And we have that the axis of symmetry is y equals 0. That's it. That's all we have to do here. So I rewrote them down there. You can fill in for the values of p. And that's it. That's all we have to do for these here. So again, I would write, when we did the review sheet, I would write these down. Having these down is going to be majorly, majorly, majorly helpful. Yes? Because all we're doing is referring back to which one we're doing and filling in the information. Because once we find the value of p, I plug it in here and here. I plug it in for the focus, I plug it into the directrix. For either one of the equations, we do the same thing. We find that value of p and we plug it in. And so these equations here are written down. You do have them on that sheet. If you see the core connection on the bottom of the first page, they are written right there. They are written right there, okay? They are right there. And I would reference those, especially when you're doing the homework. These here, and what we do for the rest of this week, I find that some students have a challenge with this. But as long as you stick with focusing on this and the steps that we do to find p, this isn't that bad. Would y'all agree with that? But as soon as you lose this, or not having this as a help, it becomes harder. Because it's very easy to flip some of these numbers and flip how we're doing this. We're going to do this again. We're going to do another one. This one here. So which variable is being squared? The x, yes? And since the x is squared, looking at our sheet, the little sheet, our reference sheet, it says the focus is 0, comma, p. The directrix is y equals negative p. Y is equal to negative p. And the axis of symmetry is x equals 0. X equals 0. And this is coming straight from our core connection, these equations, because when y equals 1 over 4px squared, when the x is squared, this information is true. It holds true. So we're looking at comparing it to this general equation. Y is equal to 1 over 4px squared. Now the equation we have is y is equal to 0.5x squared. Now what variable are we trying to get by itself? We're trying to get the x, the variable without an exponent. Well, the variable without an exponent, sorry, yes, you're right. It is y. I got it backwards. So we're trying to get y. The last two we did was x, yes? Here, x has a power of 2. So we're not trying to get it by itself. We're trying to get y. We're trying to get the y by itself. So what do I need to do to get the y by itself? It's already by itself. I don't have to do a thing. Y is already by itself. So that's awesome for us because we don't have to do anything this time. So what I can do is go on and set up, like we did on the last ones, 1 over 4p equals 0.5. Now you might have a question at this point here, don't we need to change 0.5 to its fractional form, 1/2? No, we can leave it as 0.5. There's nothing that says that p has to be a fraction. It can be a decimal. There's nothing wrong with it being a decimal. Our steps do not change. So what did we do on the last two? First step in solving for p when we had it, after we got it set up like this here. Y'all remember? We didn't divide. We multiplied both sides by 4p. Because we need to get the 4p out of the denominator. We need to get the variable out of the denominator. So we do it by multiplying both sides by 4p. Because 4p over 4p will simplify, and we'll have 1. What is 0.5 times 4? Because it's saying we are taking half of 4. So we do 0.5 times 4, which gives us 2p. We're almost done. Because what do we need to do now to get p by itself? Because these will cancel, leaving me with 1/2 equals p. So we found the value of p, yes? Plug it back in. Plug it back in. So our focus is going to be 0, 1/2. The directrix is y is equal to negative p. Well, p is just 1/2. So we get y equals negative 1/2. And that's it. Now, I had mentioned this on one of them. Because p is positive, this opens up. It opens up. It's going to open up. So that kind of gives us a hint as how to graph it, or which one of the graphs is going to work. So it should open up. And that's all we have for this one here. On the graphs, you can also use Desmos, that Desmos graphing calculator, because you won't have to graph these on the test. You won't have to pick out which one of the 4 graphs is the correct one on the test. But in Desmos, it will take the actual equation, y equals, you can type it as y equals the number, or it will also take x equals. The graphing calculators that you have will not do x equals. It only does y equals. So x equals 1 over 4p y squared, the first two we did, Desmos will graph it. You just have to type it in as x equals. That one will help you on the homework. But are there any questions on any of these that we've done so far? Are we good with these here? Yes? Because I'm going to do one, we're going to do this last one here, and then we're going to move on to the other type. So we're doing one more of these here. So when we look at this here, we should notice that x is the variable that's being squared, because we have x squared. So I'm going to refer back to the equation that it is, and that's going to be y equals 1 over 4p x squared. This is the equation we have. It also tells me, because x is squared, the focus is going to be 0, comma p. The directrix is going to be y is equal to negative p. And our axis of symmetry is x is equal to 0. X is equal to 0. Now, part of the reason we have some of this here is that the vertex for both of these here is 0, 0. The vertex where this is the highest or lowest point is 0, 0. It's at the origin. That's why the axis of symmetry is x equals 0 and y equals 0 for their respective functions. Now let's look at the equation they gave us. Negative y equals x squared. So unfortunately for this one here, it's not quite by itself. The variable we want by itself, y, is not quite by itself. It has what? It has a negative 1 with it. So we need to make it positive by dividing both sides by negative 1. There's a negative divided by a negative is a positive. Here, we get negative x squared. We get y equals negative x squared. Now, what we need to do is we need to match up our equations, because we're comparing this to y equals 1 over 4px squared. So our 1 over 4p is going to equal negative 1. Because there's not a number written there, there's just a negative sign. So that means it's negative 1. If it had just been y equals x squared, the number that we would set 1 over 4p equal to would have been just 1. Our steps are going to be the same. Our first step is going to be to multiply both sides by what? 4p. We always multiply by both sides by 4p first, because those two will cancel, leaving us 1 is equal to negative 4p, because negative 1 times 4p would be negative 4p. We have one more step to get p by itself, and that would be to do what? By negative 4. And when we divide both sides by negative 4, we get negative 1/4 is equal to p. So the focus, I'm going to just write it down here, is going to be 0, comma, negative 1/4, because again, our focus is 0, comma, p. Our directrix is going to be y equals, so negative p. Well, it's already negative, isn't it? So a negative and a negative would make a positive. So it's just going to be 1/4. As we already said, our axis of symmetry is x is equal to 0. And again, because p is negative on this one, it opens to the right or left. Well, Since we're dealing with this here, up or down, it's going to open down since the value P is negative. And that's it for this here, these here. So are there any questions on these here? So again, this isn't too bad. It's really, as long as we stick to these formulas and filling in the information, we are good. Now that brings us to the last thing we're going to cover today, and that's writing the equation. Writing the equation. So when we look at both of the equations, what is the only thing we are really missing for either one? We're missing the value of P, yes? Because that's the only thing we need to plug in. Because we have our two forms, x is equal to 1 over 4p y squared, or y is equal to 1 over 4p x squared. We have these two here. Now we'll need to figure out which one we need to use, which one we're using to find the equation. Well, this here is opening up or down, left or right. It's opening which way? Down, isn't it? It's opening down. Well, which one of our two general equation opens down? The one with x squared, isn't it? So that means the one with y squared is not the one we want. We're going to be dealing with the one with x squared. Our directrix. This line here is y is equal to 3. It's a straight line. What is the equation for the directrix for this here? For this equation? Well, it told us is y is equal to negative p, yes? So what's the value of p? Here it says it's positive 3, yes? So how can it be positive? Only if p is what? Negative 3. So if the value of the directrix is positive, the value of p is negative. If the value of the directrix is negative, the value of p is positive. It's kind of the opposite of the sign. So we get this here. Any questions on how we found the value of p? We're good with finding the value of p? Well, we have one last step. We need to find the equation, so I'm going to plug it in. 1 over 4 times negative 3 x squared. Four times negative 3. 4 times 3 is? And that's the equation. So we're using the information they gave us to find the value of p and then plugging it in. So we're using the information that was given to find the value of p and then plugging it in. Any questions on this one here? We good with this one here? Okay. Now let's look at the next one. So again, we have our two equations. Y equals 1 over 4p x squared, and x equals 1 over 4p y squared. So those are our two general equations that we have. Now this one here helped us out a little bit more than the last one, because what does it tell us? It told us the directrix is y equals negative 2.5. It kind of told us that there, yes? Well, which one of those has a directrix equation that has y equals something? This one right here, doesn't it? That's pretty much telling me I'm using y equals 1 over 4p x squared. It's that equation because it matches up to it. It tells me the directrix, y equals negative 2.5. So I have to use this equation here because it matches up with that directrix formula. Because our directrix formula is, for this equation, is y is equal to negative p. Y is equal to negative 2.5. So the value of p is what? 2.5. Since it's negative, it comes out positive from the directrix. The directrix, it changes the sign. So y equals 1 over 4 times 2.5 x squared. So this here, we can plug this in the calculator, 4 times 2.5. And it works out that 4 times 2.5 is 10. Now, when we're doing these here, if it is a decimal in the numerator denominator, we need to have it in fractional form. We need to have it in fractional form. And the calculators do fraction to decimal. So if you remember how to do a fraction, alpha y equals, the bottom one on those 4 that pop up is f with 2 arrows, d, fraction to decimal. It'll change it from a fraction to a decimal for you. But that's it. Questions on this one here? We good with this here? Okay, we're going to do at least one more of these finding the equation. But it's a hair bit easier. Because here, it gives us the focus, yes? It gave us the focus. So we have a number, comma, 0. Well, looking at our 2 foci, well, when it's x squared, we have 0, comma, p. When it's y squared, we have p, comma, 0. Well, that matches up to the y squared one, doesn't it? Because we have 0, comma, a number. 0, comma, number? Well, no. It matches up to x squared. Because our focus is p comma 0. Wait a minute, I had it right. And again, that's why I'm saying to be looking back at these formulas, because again, it's easy to get these switched. It's easy to get these mixed up. So that's why I always, when I'm doing these, I always refer back to these. I have these written down to reference and see. P comma 0. X equals 1 over 4p y squared. Because it matched up to our focus. It's what our focus is. And so here, it's just p. P is -2. It just tells us straight out. Unlike with the directrix where we have the sign change, this here, it just tells us this is the value of p. Plug it in. We just plug it in. 4 times 2 is 8. And that's it there. We just plug that value into the function, and we get our answer. We have to simplify it a little bit, but that's it. That's all we have to do for this here. That's all we have to do for this here. Questions on this here? We'll look at one last one, because this is the last one they gave us. 0, comma 3/2. Now this one here matches up to y equals 1 over 4p x squared, because y equals 1 over 4p x squared, the focus is 0, comma p. The focus they gave us is 0, comma 3/2. 0, comma p, 0, comma a number. So here, p is 3/2. Plug it in. 4 times 3/2 x squared. Well, 4 times 3/2 is 6. And that's it. That is it. And that's all we have to do for these here. Now, again, a lot of what we're doing is really relating back to these formulas and referring back to those there.